I'm doing P3 2023 January paper. So this is the Jan 2023 paper. This video is on question 2. Okay. So how I'm doing these is, if you're somebody who just wants to look at a more extended answer, here is my notes. Just scroll through here a little bit. Okay. Just pause the video, look at the notes, carry on from there. But if you need a little bit more explaining, I'm going to go through what I did there. Zoom this in a little. Okay. So question 2. Number A. Express f of x in this form. Okay, so the r cos x minus a thingy. And r and cos have to be constants. R has to be larger than 0, and a is between 0 and pi over 2. So just remember that restriction for later. Give an exact value of r and a value of a in radians. So check your calculators in radian form, also 3 decimal places. So obviously come back and check that your answer is in 3 decimal places. Okay. Let's see what happens when we do it this way. So first part of the question is, we have our f of x that was given to us as cos x plus 2 sine x. Okay. And it wants it in this form. So this form, the 2 unknowns that we need to get is obviously r and a. So that's what we're looking for. We need to convert it. So the first thing is take note that this is using cosine. So it's going to be using we need to transform this into cos sine sine. So if we expand this, it will be r cos x sine alpha plus r sine x cos alpha. This is just so this expanded using the identity, and then I times the r in to both. Okay, so that's where the r's came from. And then once we've got it in this form, we need to compare coefficients. So our coefficient of cos x from our original thing is an invisible one. So our new coefficient of cos x is r sine a. If we look at the other one, our coefficient of sine x is 2. Our new coefficient is, just careful here, with the cos sine, the signs change. So I have made an error here. This should be negative. This sign should not be the same. So it's a self-checking thing. If you look at your formula book, I make a lot of errors when I teach, so I always self-check as I go. Most of my students make these sorts of errors as well. So better to just self-check as you go. So here we have the situation where we have 2 equations that we've made by comparing coefficients. So our first one is that r sine alpha equals 1. And our other one is that r cos alpha is equal to 2. Okay, so we've compared the coefficients, and now we need to get r and we need to get alpha. That's always the goal here. You want those 2 things. So how do we get r? How do we get alpha? Just manipulate these 2 equations in order to get the 2 things. So let's start with r. In order to get r, we what do? We add these 2 equations together. So this, if just to give you a little bit more, if this is the left-hand side and this is the left-hand side, this is the right-hand side and this is the right-hand side. So we're basically adding left-hand side plus left-hand side. And we're equating it to right-hand side plus right-hand side. Okay. So we add them together. First thing, first add, and then square. So in order to find out what R is, we do this step, add and square. Okay. So add and square is what I mean, left-hand side, left-hand side. So we end up with R sine A plus R cos A equals to 1 plus 2. Now we've added, now we square. So it's R squared sine, squared A plus R squared cos squared A equals to 1 squared plus 2 squared. So we've added and squared, and now we want to just isolate R. If you take out R as a common factor over here, let's take a look at taking out R squared as a common factor. We end up with sine squared A plus cos squared A, which we know is an identity that equals to 1. So that's easy. On this side, we have 1 squared plus 2 squared. So 1 squared is 1, so it's 1 plus 4. So this is just 5 for now. So we know that our R squared equals to 5. And the last step is to square root both sides to find your answer. Obviously, the square cancels out on that side. Okay, so we're going to end up with square root 5 as our R. Okay, so we have R, and once we've got R, we need to find alpha. Now, the way to find alpha is to notice that in our two equations here, we have a sine and a cos, and we can manipulate those to look like tan. So if you manipulate those to look like tan, you'll be able to finish the, you'll be able to isolate the alpha. So if I take those equations again, just for clarity, so my two equations were somewhere here. There we go. R cos A equal 1, R sine A equals to 2. And the same thing applies. So we have left-hand side, right-hand side, right-hand side. But this time we're not going to add and square it. We're going to divide. And just note the one with sine in is the one you start with. We start with sine. I expect everybody knows that sine over cos. Okay, just by now, if you've made it through P2, oopsie, sine over cos equals to tan. That's the piece of information that I'm assuming you know. So we can just divide this. So you could literally say left-hand side over left-hand side and right-hand side over right-hand side. But you got to pick the right one. So make sure you pick the one with sine in. So we can say R sine A over R cos A equals 2. And then the same, whichever one you started with, you got to start with again. So it's 2 over 1. Okay. So just looking at this, where that is on the right-hand side. So that, as you can see, quite neatly, these R's cancel out. So you wouldn't have needed to know R. If they just asked for alpha, you don't need to know R. This becomes tan alpha equal to 2. And we know that in order to isolate alpha, we just do tan to the minus 1 of 2. Stick that in your calculator. I get, don't forget radian form. I get 1.107148718 on my calculator in radians. And they ask for 3 decimal places. So just round it off, 1.07. Oopsie. 107. Okay, that's you don't have to write 3 decimal places there. That's just from my working. So that's the answer. Alpha is equal to 1.107, and we had R as R was root 5. Okay.